Okay, so welcome back to maintenance for week 2 for the Pure Maths 1 students. As I mentioned last week, I really want you to be doing some work in your own time. It's not enough just to come to the classes and work there. You're going to need to do probably 2 or so extra hours a week on Pure Maths to keep up, and part of that is going through your maintenance booklet and watching these videos to see how you're going. Unfortunately, this video may not be super great because I recorded it with audio, but the audio didn't work, and so I'm now watching myself do the video with no audio, and I'm going to try and get that audio synced to what I'm doing. So if it sounds a bit funny, that's why. So here we go. Okay, so we're looking at quadratics. That's the first section. We're expressing 2x squared minus 12x plus 7 in this form here. So you can see that it's a completing the square type question. So what I'm going to do is I'm going to factorize that 2 out, and I'm going to use my square brackets. And then inside the square brackets I'll have x squared, and then that 12 will become a minus 6. And close the square brackets, I've got that plus 7 hanging off the end there. Now, in the next line, in the square brackets, I'm going to complete the square. So it's going to be x, half the 6, so it's minus 3. I'll square that whole thing. Now, you'll see that if I do that, I'll have this extra positive 9 out the end. So I need to make up for that by doing a subtract 9. And now what you'll see is that what I have here is the same as there. And I've got that plus 7 at the end. And so on the next line, I'm going to expand that 2 into the square bracket. So I get a negative 18 plus 7. Minus 18 plus 7 is negative 11. So next line, I'll have a negative 11 there. And we're done. Make this pen a bit smaller, it's a bit fat. So, in the second question here, what we're doing is we've got a quadratic. I'm going to bring that 30 across, and then I'll be able to solve this inequality by factorization. So, x minus 6, x plus 5, since negative 6 times 5 is negative 30, and they add together to make minus 1. Now I can quickly sketch this, and I'll have roots at positive 6 and negative 5. A bit of a dodgy drawing, but hey, it's fine. Now what are we looking at? Well, we want to know where this function, or this inequality, where is it less than 0? Well, if you look at the quick sketch I've done, it's this. And so it's between the minus 5 and the positive 6. So we take our minus 5, which is our lowest value. That's got to be less than x. And then we know that x has to be less than 6 because that's the upper value. And that's the way that you write a range. Lowest value is less than the x, which is less than the highest value. Okie dokie. Now we're doing the next one. We're trying to leave the answer in surd form. We've got this quadratic. Hey, to me it looks like we could use the quadratic formula here. That seems to be the best option. Now, of course, that's what do we know about that? Quadratic formula. So the values of x will be equal to a minus b plus or minus the square root of b squared minus 4 ac, and that will all be over 2a. I'm going to apply that. So x will be equal to minus 10 plus or minus the square root of 10 squared minus, and a is 3, so 4 times 3, and and c is 5. And that will be all over 2 times a, which is 2 times 3. Now, we'll simplify this out. So we get minus 10 plus or minus. Now, in the under the square root, so the 10 squared is 100. Negative 4 times 3 is negative 12 times 5 is negative 60. So it's 100 subtract 60, which is 40. And that's all over 6. And then we can rewrite that, negative 10 plus or minus square root. Now, square root 40, we could go, that's like square root 4 times square root 10. And then we'll put that all over 6. Next line, negative 10 plus or minus 2 square root 10 all over 6. Because square root 4, of course, is 2. Now, we can simplify this even further. So negative 10 over 6 plus... no, what we come back. All right. What we can do is I'll just clear some space here. What we can do is rewrite it as equals. Now that we can divide 10 over 6 by 2, so 5 over 3, negative 5 over 3, plus or minus 2 square root 10 over 6. But hang on a second. The 2 over 6 could be written as 1 over 3, couldn't it? So we just get rid of that 2 and rewrite that as a 3. So it's like negative 5 over 3 plus square root 10 over 3. And then the other one, of course, is negative 5 over 3, or 5 thirds, negative 5 thirds, minus square root 10 over 3. And we are done on that one. Now, we've got one of these ones. We had one last week. We're going to substitute y being equal to x squared, and therefore we can rewrite it in terms of y, so it'll become y squared minus 5y plus 4 equals 0, and then we just factorize that out, so it's y minus 4, y minus 1 equals 0, so y is equal to 4 or 1, and we know that x is equal to the square root of y, so x is equal to plus or minus square root of 4, or plus or minus square root of 1. And therefore, x is equal to plus or minus 2, or plus or minus 1. Okay, so that leads us to the end of the quadratics section of the maintenance for the week. We're going to now move on to functions. In the first one, we've got functions f and g are defined by we've got x is a member of a set of real numbers, and we've got these two different functions, 4x minus 2x squared and 5x plus 3. We've got to find the range of f. Now, with ranges of quadratics, because the f1 is a quadratic, I like to use some, the best thing to do is complete the square, and it makes it very easy for you. So here we go. I'm just going to put my minus 2x squared first, just rewriting it. Then I'm going to put in my square brackets. So I get x squared minus 2x, and then my next line I'm going to complete the square inside the bracket. So we're getting used to this now. So it's x minus 1 all squared, and then I take away that 1. Now I'm going to expand out my bracket. X minus 1 all squared, and then minus positive 2. Yeah, minus positive 2 at the end. Okay, now that's completing the square, and the range is going to be, well, we could sketch it, couldn't we? So we've got, when x is 1, that gives us our minimum point, because 1 minus 1 will produce a 0 there, and 0 squared is 0, and negative 2 times 0 is 0, and so we'll get a value of 2 at that point, and you can't go any lower than that. So we'll have a range of, the function will be greater than 2 for any point on the function. Okay, and it'll look vaguely like that. 1, 2. Okie dokie. So the reason it is a minimum point is, I better just write, so we'll write this, fx is greater than, or not equal to, is it? Yes, or equal to, yes, because we're including that. So everything will be above that. There we go. Okay. All right, we're looking for the next one, value of equal roots, when g fx equals k is equal roots. So that means one root. So what we need to do for one root is that our discriminant is going to be equal to 0. Okay, first of all, I'm going to write g of x. So f is that 4x minus 2x squared. So I will pop the 4x minus 2x squared into the bracket here. 4x minus 2x squared. And that's going to be equal to k, according to the question. Then I am now going to insert the 4x minus 2x squared into the gx. So it will become my x. So you see 5 into 4x minus 2x squared, close brackets, plus 3 equals k. And you can see here that x is that 4x minus 2x squared. Okay, now I just expand the brackets there. Expand the brackets. So what do we get? 20x minus 10x squared. So I'm just going to put the x squared first. Plus 3 equals k. Then I'm going to pull everything across over to that right-hand side. So I'll get 0 is equal to 10x squared minus 20x and plus 3. Minus 3 plus k, or plus k minus 3. And now I can apply the formula b squared minus 4ac. And since I want equal roots, or one root, it should be equal to 0. Oops. Now, why is that? Well, remember the quadratic equation is minus b plus or minus square root b squared minus 4ac all over 2a. And this plus or minus gives us two values, so long as the bit under the square root is greater than 0. Because if it's 0 and you add 0 or subtract 0, you get the same answer, okay? So we only get one root, or one answer for x, or solution for x, when that discriminant equals 0. So now I'm going to apply that formula to the quadratic I have. Minus 20 squared minus 4 times a, which is 10, times c. Now remember, c is made up of two parts, k minus 3, so I'm going to pop that into some brackets. K minus 3. Oh, poos. K minus 3. Alright. And that should be equal to 0. Now expand 400 minus 40 into k minus 3. So it's minus 40k. And then minus 40 times minus 3 is positive 120. Should be equal to 0. Combine the 400 and 120, so it's 520. Pull the 40k across the other side. Minus 40k becomes 40k. Divide both sides by 40k equals 13. Okie dokie, moving on. Next question. We are going to find the range of this following function. Okay, 2x squared minus 8x plus 14 for x. Let's remember to see the real numbers. Okay, yeah, so the hint is we want to put it into this form here. Now, this is exactly what I told you. If you're finding a range for a quadratic, you want to put it in the completed square form. Okay, so we're going to do that. Expand, factorize first. 2 square bracket x squared minus 4x, close square bracket, plus 14. We'll keep that 14 out there to make life simple. Then I'm going to complete the square inside the square bracket. So x minus 2, I've halved that, minus 4. I square that. Oh, made a mistake. Get rid of that square bracket. I've also got to subtract the 4. Close my square bracket, plus 14. And now what's inside the square brackets here is equal to here. Okie dokie. Now, so expand. So I'm going to expand the square bracket now. 2 x minus 2 all squared minus 8 plus 14. Which is positive 6. Okay, so positive 6. Okay, now we are finding the range. So I could sketch this, but I don't think it's necessary. We know that the range occurs when x is the low value, the lowest value, minimum point occurs when x is 2, and that would make the y value 6, right? 2 minus 2 all squared is 0. 2 times 0 is 0, so it will be 6, and so everything's going to be greater than 6. So that's our minimum point, 2, 6. So we would write fx is greater than or equal to 6. Alright, now this last one is somewhat nasty. Some of you may have had a little bit of trouble trying to do it. Hopefully, if you were confused, this will help you a little bit. So what have we got? We've got to prove that function hx, which is equal to 1 over x minus 1, where x is not equal to 1 and x is a member of a set of real numbers, that the composite function hhx is equal to x minus 1 over 2 minus x. Interesting. Okay, so I'll start with my composite function. I'm going to put 1 over x minus 1, which is hx, into h, right? So that becomes the x value in my second line. Right, that x there. Okay, so what are we going to get? Equals, I'll change colour, 1 over, and then I'll put what I had in the first line, 1 over x minus 1, subtract that 1, and now what I want to do is get that minus 1 in the denominator that's by itself. I want it to be have the same denominator of x minus 1. So how do I do that? Well, minus 1 is another way of writing that is x minus 1 over x minus 1 with a minus off to the side there, like what I'm writing now. Okay. So what I'm going to do therefore is go minus and then bracket x minus 1, close bracket. Okay. There we go. Now we can simplify. Get rid of that nonsense. Okay, here we go. So 1 over 1 minus x plus 1 over x minus 1. Now what does this give us? Well, this gives us 1 over, and then that's 2 minus x all over x minus 1. Now at this point you can use your fraction knowledge from back in year 5 or 6 or so. We've got 1 divided by, and then we've got a fraction, 2 minus x over x minus 1. And that's the same as multiplying by the reciprocal, isn't it? Okay, now hang on, 1 times that is just that, isn't it? So we're going to write it as x minus 1 over 2 minus x, and we are done. So there we go. Well, I hope this is helping you, team. I hope it makes sense. If you do have questions, of course, please feel free to ask me, fire a comment away on this video, or send me a message on ThinkWave. Take care.